Hello, everyone. We are back here at my factoring class. So this is where we're going to be learning to finally start breaking down the quadratic expressions. So that's kind of what we've been building up to. We've been doing, basic stuff to try and build up to this point. But even here, we're going to take this in baby steps because factoring quadratics can be difficult. So we are going to start simple. So as a reminder, a quadratic expression looks like this. It's ax squared plus bx plus c, where a, b, and c are all real number coefficients. So that means they can be positive, they can be negative, they can be fractions, they can be decimals. I promise to be fairly nice about things. I'm not interested myself in giving fraction and decimal quadratic expressions. So we're going to keep it to whole numbers, but there will be negative signs. And I want to discuss this a term. As it turns out, if a is allowed to be anything other than +1, it makes this process a lot more difficult. So factoring becomes a lot more difficult if a is 2, or if a is negative, or if a is 6, or anything like that. So what we're going to do, because we are trying to baby step our way to a good understanding, is we're just going to go ahead and allow a to be 1 for this video. We are just going to keep a as 1. We are not going to be dealing with any scenarios, except I have a couple at the end just to kind of show how much more difficult it can be. But we're going to keep a as 1 for this video. So we're essentially going to have a simpler version of a quadratic that looks like this. And before we get started actually factoring these things, I want to talk about the opposite. I want to talk about multiplying two binomials together to get a quadratic. So we're going to go this way first so we can learn how to do this backwards, which would be factoring. Now, just a reminder of regular distribution. If I have something like this, I have 5 and then x plus 3 in parentheses. Because there is no symbol between the 5 and the parenthesis, I go ahead and assume it's multiplication. And to do something like this, I will take the 5, I will what's called distribute it to both the x and the 3. So I'll take 5 times x, which gives me 5x, and 5 times 3, which gives me 15. And that is the appropriate way to handle this operation. Now, when we are distributing with two binomials, so this is how we would multiply two binomial terms together. It's kind of like a form of distribution. You'll typically refer to it or hear it referred to as foiling. But essentially, every single possible combination of multiplication needs to happen. So there's going to be 4 individual little pieces of multiplication that have to happen. So I'm going to try and do this, step by step to make sure I don't leave anyone behind. Let's say we have x times x to start. So that is x squared. We then have x times 3, which is 3x. We then have 5 times x, which is 5x. And then we have, I guess I'll do orange, 5 times 3, which is 15. You'll notice that 5x and 3x are like terms, so I can go ahead and combine them into 8x. So all in all, once I've completely simplified this, this is x squared plus 8x plus 15. Notice that I brought the positives along for the ride. So I said 5 is positive and 3 is positive. So when I multiply them together, it gives me plus 15. I go ahead and include the signs. This is important because you could have things end up being negative. We didn't have that happen here, but if you do have that, make sure that, you bring that negative sign along. And I want us to notice something about my final answer. So I'm going to try and make this a little easier to see. Notice that 8x is 3 plus 5. Notice that 15 is 3 times 5. 3 and 5 were the two numbers we started with in our binomial terms. That's not a coincidence. That happens pretty much every time. So if we have something like this, I'm going to be a little abstract. So I'm going to say, let's assume we have x plus q times x plus p, where q and p are just numbers. I just decided to call them q and p for no good reason. I know that the quadratic expression that they end up multiplying into will be something like this, where the middle term has a coefficient of the two of them added together, and the final term is the two of them multiplied together. Now, this might be a little difficult for us to see because, Q and P is a little weird. Maybe we should use actual numbers, and maybe we should actually try doing this backwards. Let's find out. Let's see how we do here. Let's say we have the quadratic expression x squared plus 3x plus 2. And I want to factor this into two separate binomial terms. And the question is, what goes here? Well, let's look at our coefficient of our middle term, which is 3. And we know 3 needs to be some number plus some other number. So P plus Q, if I'm using the sort of form that I was using before. So I need something plus something else, so addition. And 2, I would need those same two numbers to multiply to give me 2. So what are two numbers that add to give us 3 and also multiply to give 2? It's just 2 and 1. So 2 plus 1 is 3. 2 times 1 is 2. So I know, based on that my quadratic expression can be factored into the following: x plus 2 times x plus 1. Now, because this is our first time doing this, let's go ahead and be thorough. I'm just telling you that this is right. Let's actually FOIL this back out. Let's multiply everything back out and see if this holds true. So x times x is x squared. X times 1 is 1x. I'm just going to choose to call it x instead of 1x. 2 times x is 2x. And then 2 times 1 is 2. Notice our like terms here. X and 2x together should give me 3x plus 2. Okay, it looks like this does in fact work. So it's really that simple, as long as the a term is only 1, to just say, hey, what two things add to give me my middle number while also multiplying to give me my last number? So we have the right idea. Let's go ahead and take a few steps then. I want to show you something that we call prime. So this quadratic expression is special. There are many like it that share the same properties that this one has, but they're all sort of special in a way that you cannot break them down. They actually cannot be factored into two binomial terms. And this is what we call prime. So a prime quadratic simply means we can't factor it. And the reason I say that is because I can't think of any two numbers that add to give 2 and at the same time multiply to give 2. That pair of numbers doesn't exist. You know, anything that will add to give me 2 will multiply to give me less than 2, I think, right? Because if my two options are 2 plus 0 and 1 plus 1, and neither of those give me 2 as my final term when they're multiplied together. So this is a prime quadratic, and we can't factor it anymore. So if you're given this on, say, a test or some homework, you would simply write prime. You say, hey, this I can't do anything with this. And this is more of a cautionary tale from me of saying, hey, watch out. This does happen. Your teacher will be tricky from time to time and pepper these into your homework or your quizzes or your tests. So be aware that these can exist. I also want to have probably what is going to be too much of a long-winded conversation about negative signs. So we're going to go ahead. Once again, we're allowing A to always be positive 1. So we're not worried about that now. But there are 3 possible other scenarios for signs in your quadratic expression. So I guess there's 4. There's one where they're both positive. There is another one where the middle term is negative, but the final term is positive. So what does this tell us? Well, let's remember we need 2 numbers that add to give us -4, while multiplying to give us +4. So in this case, it's actually a pretty simple fix. It's -2 and -2. Right? -2 plus -2 is -4. -2 times -2 is +4. And we should be able to see more or less what's going on just by looking at the signs in our quadratic. So we always need to remember that the final term was 2 numbers multiplied together to give us something. So if the 2 things multiply to give us a positive number, then we know that must mean that either both are positive or both are negative, because that's how you would multiply to get a positive number. The only way you can multiply 2 numbers together and get something negative is if only one is negative. So this tells us, well, they're either both positive or both negative. And then the middle term, because the middle term is an addition of 2 terms, it's 2 things being added together, and it's negative, we know that, well, at least one of them has to be negative. But because we already know the information over here that this positive sign tells us there is either 0 negatives or 2 negatives, the combination of this, so we have a negative middle term and a positive last term, that lets us know, oh, they both must be negative for this to happen. So we end up here at x minus 2 and x minus 2. I'm not going to check by refoiling this all out. I did that for the first example, just to show how you would check your answer. But, you know, for the sake of time, let's go ahead and not do that for every single one. So this is an interesting thing to notice, is just like, okay, we have a negative middle term and a positive second term. That gives us 2 negatives. All right, what else have we got? So what if it's the other way around? What if the middle term is positive, but the last term is negative? So once again, the final term is from 2 things multiplied together. So we know if the last term, if we know this term here is negative, then we know that only one of the things that multiplied to get there is negative, because once again, 2 negatives make a positive. So we know that we have exactly one negative. We also know, because those two numbers add to give us a positive number, that the positive one is bigger. So we have one positive number, one negative number, and since they add to give us a positive, the positive number is larger. So in this case, I ask myself, how do I add two things together to give me +1, but also multiply to give me a -2? Well, in our case here, it is 2 and -1. So 2 minus 1 is a +1. 2 times -1, is -2. So we know that, I mean, this follows basically what I was saying before, where we know the positive number is bigger. We know that we have one positive and one negative. So this gives us our factored form. So we end up with x plus 2, x minus 1, just like that. All right, last of these sort of negative examples is, what if both are negative? What if both of them are negative? Well, we know, because this last term is negative, that we have one negative and one positive number. So the two numbers we're looking for, we have one positive and one negative. What the negative middle term tells us is that the negative one is bigger. So unlike last time, where the positive one was bigger, we know that they add our two numbers, whatever they are, add together to give us a negative number. So the negative number must be larger. So I need to find two numbers that add to -3, but multiply to -10. So I'm going to look at the factors of 10. And the obvious one to me that jumps out is 2 and 5. And I know that 5 is the one that needs to be negative to give me that -3 term. So let's see, 2 plus -5 is in fact -3. 2 times -5 is in fact -10. So I know that this factors down into x minus 5, x plus 2. And for those of you wondering, it is just as correct to write these the other way around. Both of these are acceptable. Neither one is wrong. All right. So that was kind of, all I have to say about the negative signs. Notice that we just had to do a lot of logic. We had to do some thinking. We had to talk our way through, okay, what do these negative signs mean? And it comes with practice. You'll get better at this with practice. Now I want to show quickly what would happen if we don't have an a term that is just +1. Now, this is a little more difficult to figure out. Let's go ahead and logic our way through it once again. Is to get, this isn't exactly true. There are plenty of ways to multiply two numbers together to get 2. But I am going to stick to whole numbers. So I know that this 2x squared came from one binomial having a 2x and one having an x, because when I multiply those two things together, that gives me 2x squared. I'm also lucky enough that I have positive and positive, so there's no negative signs to worry about. That's like an extra layer of complexity. And I don't have to deal with that, which is great. Now, the question is, what goes in my other spots to get to 2x squared plus 5x plus 3? Well, I do know that the last two terms, whatever these guys are, they have to multiply together to give me a +3. So I know that they're 3 and 1. I don't know what order they're in. I know I need to have one of them as +3 and one of them +1. So maybe it's like this. Maybe it is the exact opposite and it has to be like this. I'm not too sure. So let's go ahead and let's just pick one. Let's go ahead and foil it out. I'm going to go ahead and change the color of my pen just to say like, hey, this is an alternate universe where we're not sure if this is right yet. We will figure it out. So let's see, 2x times x is 2x squared. 2x times 3 is 6x. It's already not looking great. 1 times x is 1x. I'm just going to write it as x. And 1 times 3 is 3. Great. Fantastic. So I end up with 2x squared plus 7x plus 3. Okay, so not where we want to be. We're a little off. So this would imply that I chose the incorrect ordering. I want the 3 to be with the 2x, and I want the 1 to be with the x. All right. So let's see here. 2x squared plus 2x plus 3x plus 3. And I do see that those two middle terms, my two like terms, 2x and 3x, do add together to give me 5x. Okay, so we effectively found that this is the factored form of 2x squared plus 5x plus 3. But it took us a little bit of extra legwork. And you can imagine how difficult this would become if it wasn't as simple as 2. What if it was 4? Because there are multiple ways to get 4x squared, right? I could have a 2x term and a 2x term, or I could have a 4x term and a single x term, right? So now I have even more possibilities, even more options, and I have to go through and check which is right. All of them will give me wrong answers except for one. So as you can imagine, if I gave you something like the following, say I gave you 54x squared plus 24x minus 14, that would be very difficult for you to factor. There's an obvious statement here that all of these can be divided by 2, right? So we could factor out a 2 first, but still, even those numbers are way too big. And so with our sort of guess and check method, we run into a problem here because this is just too much with the tools we have available. So that's going to bring this video to a close. In the following video, I'm going to be showing you how to handle, big ones like this and just general quadratic expressions. I'm going to give you the keys to the castle. I'm going to give you a nice method that you can handle just about anything with. So stay tuned. I hope to see you in the next video.